If we can somehow show that angle 1 is congruent to angle 3, then we can say that these two segments are congruent. What justifies that? Like, let's say we do all the work. Let's say that we do show that angle 1 is congruent to angle 3. And if that's the case, then these two segments are congruent. What justifies that statement? Well, I have a bunch of things. If angle 1 is congruent to angle 3, we're done with this. We've proved this. Not yet. We'll get there. Immediately after we get here, we're going to say that segment AD is congruent to segment DC. What justifies this after saying that? Okay, converse of the base angle theorem. That's the only thing that's different about this proof, is that we're going to be using the converse of the base angle theorem. Alright, so yes, that's what we need to do. We need to use angle addition postulate, the substitution property equality, and the subtraction property equality to get here. And then once we get here, converse of the base angle theorem. And if you were to read that, it says that if two angles of a triangle are congruent, then the sides opposite those angles are congruent, making that triangle isosceles. This is the converse of that theorem. So, here we go. So if we're here, we're trying to get to that end goal. You got to break up your holes that you know are congruent. You need to break them up into the two parts, into a sum of two angles. Remember that you must only have variables when you use the angle addition postulate. I'm going to do that also for the other hole. So both of these statements that are written in black ink are justified by what postulate? Angle addition postulate. Once we have that, I know that the two holes are congruent, meaning this large angle and that large angle. So if that's the case, then I can set their sums equal to one another, being justified by the substitution property of equality. So this is going to go there, and this is going to go there. And so we're going to have the measure of angle 2 plus the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. This is just substitution, this statement in red ink. Substitution. Well, the second given information is going to help us out now because they told us that those two angles were congruent. Those are corresponding parts of those whole angles. They go with one another and they are congruent. Therefore, they have the same measure. So we can, in an equation, we can replace them for one another. So I think we kept angle 4 last time. Is that right? So we keep angle 4 again. So I'm going to replace the measure of angle 2 with what it's equal. The measure of angle 2 is equal to the measure of angle 4. So I'm going to replace that. Both of these statements written in red ink are justified by substitution property of equality. From there, on both sides of the equation, we've got the measure of angle 4. So mathematically, what am I going to do to both sides of the equation? I'm going to subtract the measure of angle 4 from both sides of the equation. And when I'm done and I simplify, I get the measure of angle 1 equals the measure of angle 3. What justifies this statement that the measure of angle 1 equals the measure of angle 3?
Subtraction property of equality.
Subtraction property of equality, because that's what we did to get there. That's how we got that equation. Well, two angle measures are equal, then the two objects, the two angles, are the same size, same shape, meaning congruent. And that's where we're trying to get to. Because once we show that the base angles are congruent, then we can use the converse of the base angle theorem to show that those sides are congruent, making that triangle isosceles. So very similar to the one we did first on page 187, but just slightly different. Just a little different. We're using the converse on number 16 on page 188. Okay, so I wanted to walk through those two proofs in great detail But now I'll just take y'all's questions for problems 1 through 20 on 189 through 190. So please raise your hand and we'll talk about those other problems. Can I erase this, or does someone still need this? I don't know how much more obvious I can be, but you are responsible for that proof, for those two proofs. I don't know how much more obvious I can be about that. All right, Ms. Natty, you have a question?
Number 20.
Number 20. Oh, I don't know how to do that one. I'm just joking. All right. You know the measure of the exterior angle of an isosceles triangle forms a linear pair with the vertex angle. All right, so that's a large sentence. A lot is going on. First off, we've got an isosceles triangle. I'm going to start there. Isosceles triangle. By the definition of isosceles triangle, it says that it has at least two sides are congruent. So there we go. Apparently, we know the measure of one of the exterior angles. Well, there's a lot of exterior angles we could create. I could extend this side and have an exterior angle over here, or I can extend this side over here and have an exterior angle here, or I could extend that side. So there's a lot of options, but it gives you a clear description of which exterior angle they're talking about. Because it says that this exterior angle forms a linear pair with the vertex angle. Well, if I made these two my congruent sides, that forces this to be the vertex angle. So apparently this exterior angle is adjacent to and supplementary, so that's the definition of linear pair, supplementary and adjacent to the vertex angle. So I'm going to label this as E. Nope, because that's a, nope, we're not going to do that. Apparently we know the measure of this angle, so I'm going to use K for no. We know that measure. I'm going to use V for vertex angle here. So it says describe two ways you can find the measures of the interior angles of the triangle. So apparently they're claiming that all we need to know is this exterior angle, and that would be enough information for you to determine the measures of all three interior angles. What piece of information is vital that we have to add into our diagram?
The two base angles are congruent.
Right, the base angles are congruent. What justifies that these base angles are congruent? What theorem?
Base angle.
Base angle theorem or the isosceles triangle theorem. Good. Well, because these two angles are congruent, I know the measures are equal. So, I'm just going to label them both B for base angle. So, I'm guessing that a lot of you saw one way to solve this problem is, well, if we knew this exterior angle, then we could just take 180, subtract the measure of this exterior angle that apparently we know. That would give us the measure of the vertex angle, and then you could take whatever the measurement of this vertex angle is, subtract that from 180 degrees and divide by 2. Is that the way that we, most of us got? So it's that second way that is the difficult. Okay. The second way is using the exterior angle theorem. Okay, so the first way, linear pair to find vertex angle measurement. Okay, so you'd say, hey, cool, these are linear pair. You'd find the value of V, whatever that measure of the vertex angle is, and then you would subtract whatever V is, the measure of the vertex angle, from 180 degrees, because you know that these three angles sum up to be 180 degrees, and then divide by 2. That's one way. Second way is using the exterior angle theorem. Someone please remind me what the exterior angle theorem says?
The measure of the
So the measure of the exterior angle, which we have called K, the measure of the exterior angle is equal to the sum
The base angles.
of the two remote interior angles. We can't say base angles because we don't, it's not always going to be an isosceles triangle. So the triangle's not always going to have base angles. So in this case, with this isosceles triangle and this exterior angle, the two remote interior angles, those two non-adjacent interior angles, they are, yes, your congruent base angles. So B plus B. So if I simplify this, we would take the measure of our exterior angle that we know and simply divide it by 2 to get one base angle. Once you have one, you have both, and then you can find the measure of the vertex angle. So these are the two ways of finding the measures of the three interior angles. Next one? Yes, Grace. Number 10. First up is on number 10, does your book at the bottom, like mine, does it have the measure of angle B?
Yes.
It does. Does any of yours don't have that?
Mine
Talk about this right here. At the bottom it says measure of angle B.
Mine has that.
That's why
Okay, so some of yours do and some of yours don't. That is a typo. That's absolutely a typo. It's not. That has nothing to do with this diagram. I don't know. It may have to go like with number 13, like they hit enter and it came back here.
That's all
I
I
don't know.
wanted to know.
Alright, sweet. Yeah. So if you have this, ignore it. If you don't have it, you're wonderful. Cool. So that was the only concern? Gracie? That was the only concern? Alright, cool. Matt?
Number 8.
Number 8. Yeah, we are changing this. Number 8 says, the measure of the exterior angle of a triangle is 84. The measure of one of its remote interior angles is 22. What are the measures of the other two interior angles? We use the exterior angle theorem for this. So it says that my exterior angle is 84 degrees. So that means that the angle it's adjacent to, the interior angle that it's adjacent to, has to be obtuse. You catch what I'm throwing? Alright, cool. So that's this one. So I'm going to extend this, and apparently this exterior angle is 84. Therefore, the adjacent interior angle must be 96 degrees. It has to be obtuse. It tells us that one of the remote interior angles, so one of these guys is 22 degrees, so determine all of the interior angles. There's a couple ways you can find this. You can take 84 and subtract 22 from it, and you get 62. Or you can just say 96 plus 22 divide, or sorry, 96 plus 22, subtract that from 180, you'll also get 62. One more, and then we gotta move on. Okay. Please make sure your name, your number, and this class period is written at the top. If this worksheet, or sorry, if this assignment's multiple pages, then please come up here and staple it.